Hi everyone, welcome back to our channel. Today we are going to discuss a very beautiful concept. There's nothing but what is the behavior of the capacitor with an DC input is given, or why a capacitor act like an open circuit with an DC input. It's very simple to understand. Let's try to apply an DC input to the RC, which are connected in series with a resistance of 1 ohm and with an capacitance of 0.1 microfarad. Now this derivation or this analysis you are going to validate theoretically with my explanation, and it will be followed with an practical of MATLAB simulation, and there we will show why a capacitor is acting like an open circuit. Okay, so this I will show to you where you will get an clarity. Okay, so this is how you can see here the current in the capacitor is 0 with an input of DC. Why it happens and how it happens, now let us try to see the simulation and theoretical. So these are very toughest concepts to understand in electrical engineering and for electronics engineering, and those are concerned with electronics. Now let's try to go into the concept. Here uh, we have an 20 volt source and we are applying this 20 volt source to the resistor as well as capacitor. So therefore this may develop an drop of VR and this may develop a drop of VC. So therefore the current which flows in the circuit is same. That current I am going to call it as the current across the capacitor. Current I is equal to C into dV by dt. So this is the total current. I mean, this I can call the current across the resistor or the current across the capacitor. Both are same. So IC is equal to C dV by dt, where dV by dt is called as the rate of change of voltage in the capacitor. So dV by dt is the rate of change of voltage in capacitor. But here when you are applying 20 volts, now let us try to see here what is the analysis under steady state analysis. Steady state analysis means we are giving this 20 volt source for a time of 10 seconds. Okay, or let's take a time of 20 seconds, or this 10 seconds will reflect as t equal to infinity seconds. Also what will happen to the capacitor? So when the current across the capacitor is equal to C d by dt, and what kind of voltage you are giving is 20 volts. Okay, so differentiation of constant is how much? 0. So C into 0, that is equal to 0. Now I equal to 0. The meaning here is the capacitor will try to act as an open circuit, and the whatever the voltage you have been applied, the same voltage will be available here, which is nothing but 20 volts. Why? Because the current is 0. So 0 into current into resistance, this also will act as an short circuit. Whatever the voltage you applied now will be available across the capacitor. Okay, so whenever the voltage you applied is already available across the capacitor, therefore the current becomes 0. Therefore the capacitor under steady state condition, which is called at a time of final state 10 seconds, or it will try to act like an open circuit. Okay, so it will try to act as an open circuit, and it will allow maximum voltage to be available across the capacitor equal to, this voltage will be equal to the source voltage. Okay, this is how capacitor will try to become a fully charged capacitor. Okay, so now the capacitor is fully charged by taking all the voltage from the source, and it will be equal to 20 volts. You can see here this is also 20 and this is also 20, with the chance of flow of current. Therefore the current becomes 0. Okay, so therefore the current will not flow. Okay, so automatically the capacitor will try to perform open circuit, and it try to become as an fully charged capacitor. So this is how we say that the capacitor with an DC input, with a DC input of 20 volts or a steady state voltage of 20 volts applied for a time of t seconds, it will try to act as an open circuit, and allow the maximum voltage which is equal to the voltage across the capacitor will be equal to the voltage across the resistor. So already I drawn a resistor. Okay, here the current is 0, automatically 0 into voltage, this will, the voltage, source voltage will be equal to the capacitor voltage. That's how the capacitor act like an open circuit in the final state and get a fully charged capacitor. Okay, therefore it doesn't allow the current to flow in this direction whenever it isn't fully charged. So this I'm going to validate with the help of an MATLAB simulation. Here it's very simple to understand. So for more clarity, I have taken a two loop system. This is an loop one system. This is a two loop system. Here I'm having an 20-volt system, and the current in this branch is 9.7, and this is a 47 ohm resistor. This is a 2000 ohm resistor, and this is a 500 ohm resistor. So the theoretical analysis of this circuit is already done in our channel under the name mesh and nodal analysis. You can see the theoretical calculation as well as the simulation also. So this is a 47 ohm resistor, this is a 2000 ohm resistor, this is a 500 ohm resistor, this is an 500 ohm resistor, and this is a small inductor injected to nullify the leakage currents, and this is the capacitor with a value of 1 microfarad. Now I am giving the voltage. Now let's try to just run the simulation. Here you can see the beauty. How much voltage I applied is 20 volts. Okay, so how much current is entering into the circuit is how much? 9.77 milliamperes is entering, and this 9.77 milliamperes will flow only in this branch. So 9.77 is entering, and what is the current which flows in this branch is 9.77 milliampere. There's no current in this branch, indicating that current in milliamperes is 0. The current in the capacitor is 0 with an DC input is given. So the capacitor is offering 0 current under steady state condition, and this voltage, what is the voltage at the capacitor? What is the voltage we have at the source? You can see here that voltage across this 2 ohm resistor is 19.54. These two will be in parallel, right? Automatically the voltage is 19.5, the same voltage is maintained. Okay, the voltage across this parallel resistor will be the voltage across the capacitor. Here current is 0. Okay, so 0 into R is voltage is 0. 0 into inductor is also 0. Therefore the no current will flow in this branch, and the voltage across this will be available across the 2000 ohm resistor. When you see the voltage, what is the voltage we applied? KVL 20 volts we applied. Okay, and what is the drop across this resistor? 0.5. 0.5 plus 19.5, which is equal to 20. KVL is also verified, and KCL. So here 9.7 I applied, this will flow in this branch, and same 9.7 will flow. There's no current in this branch. That's why the current in the capacitor under steady state condition is 0. Okay, it is not allowing the current to flow. Automatically the current is 0, and what is the voltage available is equal to the source voltage. Now the capacitor act like an open circuit, and the voltage across the capacitor is equal to the maximum voltage. That's why available across the parallel branch. That's why we generally suggest connect this capacitor in parallel to the source only. Capacitor should be all the time connected in parallel, such a way that it will nullify the voltage variations, and inductor should be all the time connected in series connection. That's what how it acts like an energy storage device. Hope with this explanation you are very clear that why a capacitor act as an open circuit with an DC supply, and this is the MATLAB verification to justify the answer. Okay, so now we can see the theory to what I have been concerned. So whenever DC voltage is given, automatically at t equal to 10 second, what happens here is, so around 20 volts is available, and there is no rate of change of voltage. Suddenly there is no rate of change. Suddenly you had applied 20 volts. Whenever the voltage is constant, the current becomes 0, and it acts like an open circuit, and the voltage across the capacitor is equal to source voltage. Why? Because this, the resistor is offering 0 current, automatically 0 into R, where it acts like a short circuit, and the voltage across the source is equal to voltage across the capacitor. This is what the behavior of an capacitor under steady state condition. The behavior of the capacitor is reverse under the case of transient state. We'll do and one more video how to understand the behavior of a capacitor under transient state as well as under steady state. This is the brief explanation about why a capacitor acts as an open circuit under DC supply or under steady state condition. It's very clear. Hope you are able to understand. If you feel my explanation is good, please give an like to the video and share with your friends. And if you have any doubts, let me know in the comment section. I will answer your doubts. Thank you for watching the channel. We'll meet with an another beautiful video and beautiful explanation. So these are the major doubts for electrical students. What's happening when a DC supply is given to an inductor? What's happening when a DC supply is given to the capacitor? What sir is saying is correct or not? What actually his explanation is? So that's why I validated it with an MATLAB simulation. Hope you are able to understand what I want to convey to you. So watch more videos. You can understand the transient behavior of the inductor. I will compare with an practical system. So hope you are able to understand the content. We'll meet in another beautiful video. Thank you for watching. Yours Ram.